Okay, so we're working on GCSE Edexcel SLR3 data representation, and we've already had a look at how we can do binary shifting, so left shift to multiply a binary number and right shift to divide a binary number. And now it is worth us just having a little look at what the difference between a signed integer and unsigned integer is. Now, first of all, let's look at an unsigned integer. This is what we are used to using. So if I put a number in here, we know that this is equivalent to, yes, you guessed it, the denary 12. Okay, now this is a positive value. What if we wanted to represent a negative value? Okay, a minus number. So how do we do that? Well, we use a signed integer. Okay, now that means that we no longer use the leftmost bit, which we call the most significant bit. We no longer use that as part of the calculation for a number. Okay, we're now going to use it. Think of it as a plus or a minus, and if it is a 0, it is a positive number, and if it is a 1, it is a negative number. So if I wanted to represent a negative number, I put a 1 here, and that is like saying minus 128. That is our starting point. So if I put zeros all along here, excuse the handwriting, and put a 1 here, it is like saying minus 128 plus 1. So this value, which is a signed integer, is equivalent to denary minus 127, because that is minus 128 plus 1. Okay, and we can represent other values. So what if we put a different value in here? So we'll still do a negative number, so a signed integer, which is using this most significant bit to represent a negative number. And if we put a 1 here, what is the denary value of this? Well, we start at minus 128 and we're adding 64. Now you could sort of start muttering away and doing lots of mental arithmetic, but actually we know there are two 64s and 128 because all of this goes up by the power of 2. So two 64s make 128. So we know minus 128 plus 64 is going to be equal to minus 64. So this binary number, this signed integer binary number, is equivalent to the denary value of minus 64. Now what if we put a 1 in here? What value is being represented here? So minus 128, because there's a 1 in the MSB, there's a 1 here, so we add 64, which gives us minus 64, and then we add 1 here, which gives us minus 63. Now what if, let's tidy this up a bit, what if we added 1, 1, 1, 1, 1, 1, 1 here? What is the denary value being represented here? Okay, so we know minus 128 plus 64 is equivalent to minus 64. Minus 64 plus 32 is equivalent to minus 32. We know that minus 32 plus 16 is equivalent to minus 16, and you guessed it, this is now going to be minus 8, minus 4, minus 2, minus 1. So if we've got all ones on here, the number being represented, the denary number being represented, is minus 1. Let's do a couple more. So remember that we are now dealing with signed integers. which means that the leftmost bit can no longer be used to represent the number itself. It is like a plus or a minus number. So let's do another one. So we've got 1 here, which means it's going to be a minus number. So if we do something like that, what is the number being represented? So it's minus 128 plus 8, which means we are now at minus 120, plus 1, which means we are now at minus 119. So the number being represented, the signed integer, is minus 119. Now, signed integers can be positive or negative numbers, which causes some confusion because we can represent positive numbers using unsigned integers, can't we? But you know, imagine that you've got a program that is constantly changing what is the values being saved to variables, and maybe that is sometimes a positive number and sometimes a negative number. So we need to use a signed integer for that. So you can have a signed integer that is a positive number. Okay, remember the computer will always know, and therefore you will always know in a test situation, whether this is being used as a signed integer or an unsigned integer. So this is still the most significant bit. This is still a signed integer, even when it's got a 0 in here. So if I do this value here, we have a positive value, which is 16 plus 2 plus 1, so 16, 18. So this is a positive value of 19. Now it looks like an unsigned integer, doesn't it? But it is a signed integer. Okay, the computer knows it's a signed integer. And you sometimes get a question that asks you, what is the highest positive value you can represent with an 8-bit signed integer? Okay, so let me ask that question again. What is the highest value that we can write with an 8-bit signed integer? And it's a bit of a trick question because, you know, if we want to represent as high a number as possible, if it was an unsigned integer, we would just do 1s in all of these, and that would be equivalent to 255. But this is a signed integer, so don't fall into that trap, okay? This is a signed integer, so we can't put a 1 in here to represent a positive value, because that would make it a negative number. So the computer knows it's a signed integer, so if we want a positive value, we have to put a 0 in here, representing a positive number. Okay, and now if we want it to be as high a value as possible, we use all other 7 bits to put a 1 in there. So the highest possible value that we can represent using 8-bit signed integer is 127. Because if we tried to put a 1 in here, that would make it a negative number. So don't be confused. Remember, the computer will know whether it's dealing with an unsigned or a signed integer. And if it is an unsigned integer and we do something like this, we know that an unsigned integer with a number like this is going to be 128 plus 1, so that's 129. Okay, so that is an unsigned integer. But if we knew this value was a signed integer, we know that this is starting at minus 128, and then we add 1, which takes us to minus 127. So this value hasn't changed that I've written down, but I just changed it from an unsigned integer to a signed integer, which means that the outcome we get is different. And you won't ever be asked to guess that. You'll be told in the question, you know, whether we're dealing with an unsigned or a signed integer. So in summary, if it's an unsigned integer, we can use all 8 bits to create the number, and if it is a signed integer, the leftmost bit, the most significant bit, will represent a 0 here if it's a positive number, or it'll have a 1 here to represent a negative number. And if we're calculating the denary of a negative number, we start with 128 and then we just add along to calculate the denary number. So let's do some practice. So question for you. Let's do an unsigned integer first. What is this value as an unsigned integer? Okay, so pause the video while you are working that out, and I will tell you the answer in 3, 2, 1 now. Okay, so this is an unsigned integer, so we can use all 8 bits, and 8 plus 2 plus 1 is positive value 11 in denary. Okay, another question. So we are again doing an unsigned integer, so what is this value as an unsigned integer? Okay, so answer in 3, 2, 1, so 128 plus 1 is 129, and this is a positive number, and it's an unsigned integer, so don't be treating that like it's a negative number. Right, so I do recommend not just watching this passively, and if I say pause the video, actually do pause the video and have a go, because that is how you embed and understand this into your long-term memory. So let's do another one. Okay, so let's do a signed integer this time. So what is this value as a signed integer? So pause the video, try and work out the answer. Answer in 3, 2, 1. Okay, so it's a signed integer. That means this is an MSB, a most significant bit, which means that we are starting on minus 128, and we are adding 2, which gives us a value of minus 126. Well done if you got that right. Let's do another one. So let's do another signed integer. Okay, so what is this value as a signed integer? Okay, so pause the video, work out the answer. Answer in 3, 2, 1. Okay, so it's a signed integer, so that means that is an MSB, so that means it's going to be a positive number. So 8 plus 2 plus 1 is 11, so it's positive 11. Okay, let's do another one. What should we do? Positive or negative? Signed or unsigned? Okay, unsigned integer. This is an unsigned integer. What is the value being represented here? It is an unsigned integer. Pause the video. Answer in 3, 2, 1. Okay, so it's an unsigned integer, so this is not an MSB. So it's 128 plus 8, which is 136, plus 2, 138. So the answer is 138. It's a positive number. Okay, let's do another one. Okay, a signed integer. Okay, so this is a signed integer. So what is this value here? Okay, pause the video, work it out for yourself. Okay, you've unpaused, answer in 3, 2, 1. So we know it's a signed integer, so we know we're starting at minus 128 plus 8 gives us minus 120, plus 2 gives us minus 118, plus 1 gives us minus 117. So the answer is that this signed integer is representing the negative number minus 117. Okay, so let's do another one. So this number if this was a unsigned integer, what is the value being represented here? Pause the video, work it out. Okay, unpause, let's work it out. So it's an unsigned integer, so that means it's 128 plus 16 plus 2. Now, some of you may be much better at mental arithmetic, but particularly in a test situation, there is nothing wrong with writing this out in longhand. So 128 plus 16 plus 2, see I almost made a mistake there. So 8 plus 2 is 10 plus 6, so we put a 6 here, carry the 1, so 1, 2, 4. Okay, so the answer is 146. Okay, so 128 plus 16 plus 2 is equivalent to 146. Okay, so let's throw you a curveball. Let's keep the values the same, but instead of it being a unsigned integer, this is now, we've changed it. What is the outcome if it is a signed integer? So pause the video, have a go yourself. Right, unpausing, so let's work it out. So this is a signed integer now. So this is an MSB, so it's represented as 128 as our starting point, and we're going to add 16. So 128 add 16 is minus 116. Is that right? 6 minus. No, it wasn't right. So it's not 116, is it? It's 128 minus 16 is minus 112. Nearly made a mistake. Okay, so minus 112 add 2 is equivalent to minus 110. Okay, so hopefully those experiences have been useful in understanding this term that gets bandied about unsigned and unsigned integers. And we're about to start talking about 2's complement in a minute, and 2's complement is pretty much the same as a signed integer.